are going to complete the specimen paper for 2025. If you'd like to skip to a specific question, click on more below for the breakdown.
In question 1, we have to write down the integer values of x that satisfy the inequality x is greater than or equal to -2, but less than +2. So an integer is a whole number which can be positive, negative, or 0. So the values of x will be -2, -1, 0, and 1. Okay, so there's the first question. In question 2, it says in triangle PQR, QR is equal to 10 centimeters and PR is equal to 11 centimeters. Using a ruler and compasses only, construct triangle PQR. The line PQ has been drawn for you. Okay, so there's the line PQ. I'm going to start by looking at the distance here from P to R. So you must take your compass and make sure that the compass point and the pencil tip have a distance of 11 centimeters between them. Okay, so once you set your compass, you need to place the compass point on letter P, so at the top of this line. And once that's in place, you must draw a big arc all the way across your paper, like so. Okay, so the distance between point P and this arc is always 11 centimeters. Next, if we look at the distance from Q to R, this time you need to set your compass to 10 centimeters and make sure you do this really accurately. Okay, and now you have to place your compass point on letter Q, so at the bottom of the line down here. And with that in place, you draw a second arc all the way across your page, like so. Okay, so where those two arcs cross must be the point R. So all that's left to do to finish is to join up the points. So take your ruler and join up P with R, and always just check that it's definitely 11 centimeters when you do this. Okay, and when you join up QR, that it's equal to 10 centimeters. Okay, and make sure you leave the arcs in place because you will get marks for those. There's question 2. In question 3, we have to simplify. Now, because we're dividing in this question, it means we have to subtract the powers on the letters which are the same. So if we take the letter x to start with, we have x to the power of 8 divided by x to the power of -1. Remember I said we're subtracting the powers. So we have 8 take away -1, which is the same thing as 8 plus 1, which is 9. So the power on the letter x is 9. Okay, so there's the first part. Now if I have a look at the letter y, I have y to the power of 7 divided by y cubed. And remember, we have to subtract the powers. So 7 take away 3 is 4. So the power on the letter y is +4. So there is the answer to question 3. Now, in question 4, it says f of x is equal to 3x minus 5. The domain of f of x is -3, 0, 2. Find the range of f of x. Okay, so the range is just the set of numbers that this function can produce. And what you have to do to work it out is substitute these numbers one by one into the function up here. Okay, so if I start with this first number here, -3, it means I'm working out f of -3. So you're replacing the letter x in this function with the number -3, and then you have to calculate it. Okay, so 3 multiplied by -3 is -9, and remember you're subtracting 5. So -9 take away 5 is -14. So that is the first number. Next we have to work out f of 0. Okay, so this time we're replacing the letter x with 0 instead. And again, we have to calculate. So 3 multiplied by 0 is 0. And remember, you're subtracting 5. So 0 take away 5 is -5. Last but not least, we have to take this value here, +2. So we're working out f of 2. So 3 lots of 2 take away 5 gives us 3 times 2, which is 6. take away 5, which is 1. Okay, so there is the range of f of x. In question 5, it says two towns A and B are shown on a map. The scale of the map is 1 centimetre to 3 kilometres. In part A, we have to find the actual distance between A and B. So to work out this actual distance, you need to take your ruler and first measure the line between points A and B. So when I measure this line, I find that it's 11 centimetres. But remember, we have to work out the distance in real life. So because the scale tells us 1 centimetre on the map represents 3 kilometres in real life, we have to multiply this distance by 3 to work out the actual distance, okay? So I get 33 kilometres. If when you do this question, you get something that's almost 33, it doesn't mean that it's wrong. In the mark scheme, they allow anything between 32.7 up to 33.3. Okay, anything between there is fine. It just means that you might have measured here 10.9 or 11.1 instead of exactly 11. Okay, in part B, it says measure the bearing of B from A. So if we're measuring from A, you need to put your pen or pencil on the north arrow of A and turn clockwise until you hit the line that goes to B. So this is the bearing that you need to work out. Okay, so you have to take your protractor and you line your protractor up so the center of your protractor falls on point A. Okay, 0 should be in line with your north arrow, and then you count round on your protractor until you get to this line, and you should find that you get something around 120 degrees. Okay, just like before, the mark scheme does actually allow for some error here. As long as your answer is between 118 degrees and 120 degrees, you will get the mark. Okay, in part C, it says calculate the bearing of A from B. And we have to make sure we show all our working in this question. So from B means you start on the north arrow of B, and again you go clockwise around B until you hit the line traveling to A. So this is the bearing that we need to work out. Now hopefully you know that when you have parallel lines, so in a bearing question, these north arrows will always be parallel to each other. These inside angles always add up to 180 degrees. Okay, so remember in part B, I already worked out that this angle here, x, was 120 degrees. So I know that angle y is going to be 60 degrees because 180 minus 120 is 60. Okay, I also know that angles around a point always add up to 360 degrees. So if this one is 60 and I'm trying to work out this bearing, I just have to subtract 60 from 360 to work it out. Okay, so the answer is 300 degrees. But just like before, the mark scheme does allow for some error as long as your answer falls between 298 degrees and 300, you will get the marks. But do remember to show your working out in this last part. In question 6, it says a solid metal cuboid has a volume of 600 centimeters cubed. The base of the cuboid is 10 centimeters by 12 centimeters. Calculate the height of the cuboid. Okay, so a cuboid will look something like this. Okay, and let's call this the base, the height, and the length here. To work out the volume of a cuboid, we multiply the base by the length by the height. Okay, so you just multiply the 3 dimensions together. Okay, so the reason I've written down this formula is because they've given us the volume up here, so this is going to be useful. So instead of writing the letter V, we can replace it with 600, since that is the volume. We also know the base and the length here, okay? It tells us the base of the cuboid is 10 by 12, okay? So I can also replace these letters with 10 by 12. And the height is what we're trying to work out, okay? So I'm going to leave that as letter H in the formula. So if we're solving this equation to calculate the height, I have to divide 600 by 10 and also by 12. Okay, so when I work this out, I find that I get 5, so the height is 5 centimeters. In part B, the solid metal cuboid is melted and made into 1,120 spheres, each with radius 0.45 centimeters. Find the volume of metal not used in making these spheres. So to work out the volume of metal not used, we need to take the total volume, so the volume of the cuboid from part A, 600, and subtract the volume needed to make the spheres, okay? So let's work out the volume of one sphere to start with, okay? So the volume of a sphere is found using this formula over here. V equals 4/3 pi r cubed, and remember you're given this formula at the beginning of the paper, okay? So to work out the volume of one of these spheres, we have to multiply 4/3 pi with 0.45 cubed, because remember the radius is 0.45. Okay, so when you put this in the calculator, you get 0.3817 and so on. But remember, this is one sphere, and we have to work out 1,120. So you need to remember to multiply this answer, okay, so 0.3817 by 1,120. Okay, so when you multiply that, you should get 427.507 and so on. So this is the volume of all of the spheres. Okay, so to work out the volume of metal not used in making the spheres, you have to subtract this answer, 427 and so on, from 600. Okay, and when you do that, you should find you get 172.492 and so on, okay? But remember, in the exam, we're meant to round non-exact answers like this to 3 significant figures. So I'm going to count here, 1, 2, 3. Check the 4th figure. This is smaller than 5, so it doesn't round this 2 up. So I'm left with 172 centimeters cubed. In question 7, it says, on any day, the probability that it rains is 1/3. When it rains, the probability that a mirror goes fishing is 3/5. When it does not rain, the probability that a mirror goes fishing is 3/4. In part A, in a period of 60 days, on how many days is it expected to rain? So we know the probability that it rains is 1/3. Okay, so if we want to work out the number of days it's expected to rain, you need to take the total number of days in that period, so 60, and multiply by the probability 1/3. So 60 multiplied by 1/3 is the same as 60 divided by 3, which is 20. In part B, it says complete the tree diagram. So to do that, we have to fill in the missing probabilities along these dashed lines here on the tree diagram. Okay, so I can see that they filled in this probability here. This is the probability that it rains, which is 1/3, and we were told this at the beginning of the question all the way up here. Okay, so the probability that it doesn't rain must be 2/3. Remember, these probabilities here on the opposite branches in the tree diagram, they always add up to 1 because the sum of probabilities is equal to 1. So 1 minus 1/3 is equal to 2/3. Okay? Next, I can see that they filled in this information here. This is the probability that a mirror goes fishing when it rains. Okay, so again, we were told this probability at the beginning of the question, 3/5. So the probability that she doesn't go fishing when it rains must be 2/5. And I know that because these probabilities here on the opposite branches add together to give 1, and 1 minus 3/5 is equal to 2/5. Okay? Here on the last 2 branches, they haven't filled in any probabilities, but I can see there's some more information at the top of the question here. It says when it does not rain, the probability that a mirror goes fishing is 3/4. Okay, so here is the branch for when it doesn't rain, and this is the branch for when she goes fishing. So here I must fill in 3/4 for the probability. So the probability that she doesn't go fishing when it doesn't rain must be 1/4. Remember, these two probabilities here add together to give 1, and 1 minus 3/4 is equal to 1/4. Okay, so I filled in the probabilities on the tree diagram. Now, for part C, it says find the probability that on any day Amira goes fishing. Okay, so we have to be careful because there's more than one scenario to consider. Either it rains, so I'll put a Y for yes for rain, okay, and she goes fishing, okay, or it doesn't rain, so no rain, and again, yes to fishing. So when we travel along the branches, so yes to rain and yes to fishing, you have to remember to multiply the probabilities together. So in this case, it's going to be 1/3 multiplied by 3/5. When we look at this scenario, so no rain and yes to fishing, that's going to be 2/3 multiplied by 3/4. Okay, and then lastly, you must remember to add together the different scenarios. Okay, so when you calculate that, you should get 7/10, or if you write 0.7 or 70%, that's okay as well. In question 8, it says, on the grid, draw the lines y equals x and x plus y equals 7. So I'm going to start by drawing this line here. So this line goes through the origin and these points here. Hopefully you can see that the y coordinate always equals the x coordinate as we travel along this line, okay? So whenever you draw graphs in the exam, make sure you use a pencil. And if it's a straight line like here, make sure you use a ruler as well. Okay, so that is the first line, y equals x. Now, if we look at this one here, x plus y equals 7. There's a nice easy way to remember how to draw straight lines when the equations rearrange like this. Whenever you have x plus y equal to a constant, you know that the straight line is going to intercept the x and the y-axis at this same constant. So in this case, 7. So it's going to intercept the x-axis at 7 and the y-axis at 7. And you only need 2 points along a straight line to be able to draw it. So I can join those points up. And there is the second line. In part B, it says region R satisfies the 3 inequalities. Y is greater than or equal to 0, y is smaller than or equal to x, and x plus y is greater than or equal to 7. On the grid, label the region R. So what I suggest you do on a question like this is to shade the unwanted regions, so the opposite of what it's saying in these inequalities. Okay, and then the region that's not shaded at the end will be your region, which you can label as R. Okay, so let's consider this first inequality here. It says that y is greater than or equal to 0, which means we want to shade when y is smaller than 0, i.e. when y is negative. Okay, so it's not actually drawn on the exam paper, okay, this part. When y is negative, that would be everything below here. So you don't really need to shade this part, but I'm just shading it just so you can see which part you would discount, okay? For this part here, it says y is smaller than or equal to x. So when we consider this inequality, we need to look at this line that we drew earlier, y equals x. It's saying that y is smaller than or equal to x, so you must shade when y is greater than x. So you want to shade when y is big, okay? You hopefully can just see, using common sense, that everything above this line is when y is greater than x, as you're going up, 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 and that's when y increases, okay? Now let's look at the last inequality. X plus y is greater than or equal to 7. So we need to shade the unwanted region, remember? So we need to shade x plus y is less than 7. So we're looking at this straight line here that we drew, x plus y equals 7. So if we want to shade x plus y is smaller than 7, we want to shade everything underneath the graph, as that is when it's going to be smaller than 7. Remember, along the line is equal to 7. So we're left with one part that's not shaded, so this must be our region R.
In question 9, it says the diagram shows the speed time graph of part of a car journey. We have to find the deceleration of the car between 10 and 13 seconds. So the section of the journey between 10 and 13 seconds is at the end here. Okay, this part of the graph. And if we're finding out deceleration, we're interested in the gradient of this line. So to work out the gradient or the slope of this line, I'm going to use a method called rise over run. The rise is just the difference in the vertical values, so 8. And the run is the difference in the horizontal values here, so 3. And you can see that the gradient, the slope of this line is negative, so that is the gradient of the line. However, in the question, it says find the deceleration of the car. So when you write down your final answer, you don't need to include the negative sign, okay, because the word deceleration takes that into account. Had the question said find the acceleration, okay, for this part of the graph, then you would include the negative sign because you can see it's actually deceleration. But that's not the question here, okay? In part B, it says calculate the total distance travelled during the 13 seconds. Whenever you have to calculate distance, you have to work out the area underneath the graph. So if we're working out the total distance, we want to work out this total area here. You can see that the shape is a trapezium. And so to work out the area of a trapezium, we add the parallel sides together, A and B. We multiply by the perpendicular height, and we divide by 2. Okay, so this parallel side at the top has a length of 10. This parallel side along the base has a length of 13. The perpendicular height here is 8. And remember, you have to divide by 2. And when you calculate this, you should find that you get 92 meters. Alternatively, you could have worked out the area of the rectangle and added the area of the triangle, and you should get exactly the same answer. In question 10, we have to factorize. So we need to put this expression below into brackets. Okay, and to do that, I'm going to look at the first two terms, 2x plus 6, and I'm going to look for the highest common factor. So the highest common factor in 2x and 6 is 2. Okay, it's the only thing that's common. So inside the brackets, I should have x plus 3. Okay, you should be able to see if you now expand those brackets, 2 times x is 2x, 2 times 3 is 6. It takes us back to here. Okay, so I'm just factorizing those first two terms. Now I'm going to do the same thing over here. The highest common factor in negative 3xy and negative 9y is negative 3y, okay? So all of these are common in those terms. And so inside the brackets here, I need to have x plus 3. Always just do a check here. Negative 3y times x should give you 3x, negative 3xy, and negative 3y times 3 should give you negative 9y. A tip here also is these brackets here, you should expect them to be the same, okay? So if they're not, you probably made a mistake, so go back and have a check. So now the last step is to write down the bracket that's been repeated, so x plus 3. And in the second bracket, you need to write down the terms that are not in the bracket. So positive 2, take away 3y. Okay, and now I have factorized. In question 11, we've been given a Venn diagram, and in part A, we have to work out the number of elements in A intersection B. But before we can work this part of the question out, we need to complete the Venn diagram, as it's only been partly completed with one number written on here, okay? So let's have a look at this information given in the question to see if we can complete. So this part at the beginning here, this means the total number of elements is equal to 20. This part here means the number of elements in the complement of A union B is equal to 3. All that means is the number of elements that are not in A union B, so both sets, is equal to 3. And that part of the information is actually written on here, okay? So that part has been dealt with.
Okay, here it says that the number of elements in set A is equal to 10 and the number of elements in set B is equal to 13. But we don't know the number of elements in A intersection B, i.e. the overlap. So for the moment, I'm just going to write the letter X in the overlapping part. Okay, so if I try and write a number for set A over here, what I can do is take the number 10 from here and subtract x. Okay, as you can see that if you add 10 minus x to x, the x and the negative x cancel each other out to leave you with 10. Okay, so now it says that there are 10 elements in set A. So if I do something similar for set B, I will take the number 13 and again subtract the overlapping part, so that now if I add 13 minus x to x, it gives me 13, and so I know there are 13 elements in set B. Okay, so from here I can form an equation as I know the total number of elements is equal to 20. So I'm going to add together everything on the diagram and put it equal to 20 to form an equation, and then I can solve it to find x. Okay, so I'm going to start by writing down the positive 3, so outside the sets, adding 10 minus x, then adding the overlapping part, positive x, and then 13 minus x. So I'm adding everything on my diagram, and I have to put it equal to 20 because that is the total number of elements. So now if I just simplify this equation, here I've got x minus x, which is 0. Here 3 plus 10 is 13, and if I add another 13, I get 26. So now I have 26 take away x equals 20. And so 26 take away 20 is equal to x, and so 6 is equal to x. Okay, so here on the overlapping part, I can write the number 6, okay, as that is the value of x. In set A, I now have 10 minus 6, as remember the value of x is 6, so that comes to 4. And over on the right-hand side, we have 13 take away 6, which is equal to 7. Okay, so now the Venn diagram is complete. I can answer the question, okay? So going back to part A, this means find the number of elements in A intersection B. Okay, so that's always the overlapping part of these two sets. So we just work that out to be 6. For part B, it says find the number of elements in the complement of A intersection B. So in words, that means find the number of elements that are in set B and at the same time they cannot be in set A. Okay, so that will be these ones here. Okay, these are in set B but they're not in set A, so the answer is 7. In question 12, it says the height, h centimeters, of each of 100 students is measured. The table shows the results. Calculate an estimate of the mean. Okay, so whenever you're given a frequency table like this and class intervals for the height in this question, the first thing you have to do is work out the midpoint for each class interval, okay? Then once you have the midpoint, you multiply it with the corresponding frequency and you add as you go along and divide by the total number of students. So in this case, it's 100. Okay, so I'm going to start by working out the midpoint for the first column. So the midpoint of 100 and 150 is 125. Okay, it's just the number that's exactly in between those two numbers. So the midpoint of 150 and 160 is 155. The midpoint of 160 and 165 is 162.5. And for the last one, the middle of these numbers is 175. Now, if you're not sure how to work out the midpoint and you'd like a method, let's just take this one for an example. You're just working out the mean of these two numbers. So you're adding them together and you're dividing by 2 because there are two numbers, and that is how you get 162.5, for example. Okay, so that is how you calculate the midpoint. So now I'm going to take the first midpoint, 125, and multiply by the corresponding frequency, 7. Then I need to add and do the same thing with the next column. So the midpoint here is 155. I must multiply by the corresponding frequency 30, and I keep doing that all the way through my table. So the next point is 162.5, and the corresponding frequency is 41. And lastly, 175 multiplied by 22. Okay, so just make sure that you either use the fraction button or put this in brackets before you divide by the total number of students, so in this case 100, just so you're not dividing the last part by 100, you're dividing everything by 100, okay? So when you put that in the calculator, you get an exact answer. So write all of these digits down. Is 160.375, okay? You only round to 3 significant figures if the answer is not exact, okay? But here you can see it's an exact answer in the calculator, so you leave it as it is. In question 13, it says the diagram shows a quadrilateral ABCD formed by 2 triangles ABC and ACD. ABC is a right angled triangle. In part A, we have to calculate angle BAC. So angle BAC is this one here. So we're trying to work out an angle in a right angled triangle. Okay, so we're going to use SOHCAHTOA to help us work out this angle. I can see that I have the opposite side over here to the angle and the adjacent side to the angle. So since I'm using O and A, it's TOA. So I know I need to use tan, and because I'm finding an angle, it's going to be tan minus 1 of the opposite, so 14, divided by the adjacent, which is 12. Okay, so remember, you have to round angles to 1 decimal place. So in the calculator, you get 49.3987 and so on. So if I want 1 decimal place, I have to check the second number here to see if it rounds the first number up, and since it's the number 9, this rounds the 3 up to a 4, so I'm left with 49.4 degrees. In part B, we have to calculate BD. So if we just go back to the diagram at the top here, the length BD is this one, okay, so we have to work out this length. What I've done, just to start with, is I've redrawn this triangle here down below, okay, as I think it's easier just to see what's going on, and I've labelled on all the information that we know so far, okay, so this length AD is 15 centimetres, AB is 12 centimetres, and we also know this angle, okay, if we just go back to the top here again, we were told this angle was 62 degrees at the beginning, and in part A, we worked this angle out to be 49.3987. So if you add this angle 49.3987 to 62 degrees, it gives you 111.3987 and so on degrees, okay, so that's the angle in the triangle down here. Okay, so we're trying to work out this side here, opposite the angle. So it's a question with a triangle involving 3 sides and an angle. So I know I need to use the cosine rule for this question. So I've just rewritten out the formula here for you. Remember, you're given this formula at the beginning of the exam paper. Okay, and so what I'm going to do next is I'm just going to label my triangle with A, B, and C, so I know how to substitute into the formula correctly. Okay, so I'm going to start with this here, angle A, okay, and it's just by coincidence already labeled with capital A, which means that this over here is side A, okay, and that's handy because that's the one we need to work out. B and C, it doesn't matter which way round, we label those two, okay? And now I can substitute into this formula, okay? So remember, we're starting with little a squared, okay? So this is the one we're trying to work out. And this is equal to b squared, so 15 squared, because b is 15, plus c squared, so 12 squared, minus 2 lots of b multiplied by c multiplied by cos of angle A, so 111.3987. Okay, so I'm just keeping that exact answer on my calculator screen from earlier for that angle, okay? So that will give us A squared if we put it in the calculator, but I want to work out the length of A. So I need to undo this, okay? The opposite of squaring is square rooting, so I'm going to square root 15 squared plus 12 squared, okay? This is what I'm going to put into the calculator to work out the length A, i.e. BD. Okay, so when you put all of this into the calculator, you should find that you get 22.368 and so on. Okay, and remember for lengths you have to round to 3 significant figures. So I'm going to count 1, 2, 3, check the 4th figure, and since it's the number 6, it rounds the 3 up 1. So I get 22.4 centimeters. In part C, it says calculate the shortest distance from D to AC. So let's go back to the diagram up at the top, okay? The shortest distance from point D to AC is the line that's perpendicular to the line AC, okay? So this is at a right angle. So you can see that there's a right angle triangle here, okay? And we're trying to work out this length here. I'm going to call it x. So we're working out from D to here. Okay, so if we're using a right angled triangle again, we need to use SOHCAHTOA to work out this length. I'm just going to redraw the triangle down here. Okay, so there's the right angle. This is 15. This is the side that we need, and this angle is 62 degrees. Okay, so I'm going to label my triangle first. This is the hypotenuse, it's opposite the right angle, and this length x is opposite the angle 62. So since I'm using the opposite and the hypotenuse, it's so I need to use sine. So I'm going to write sine followed by the angle, sine 62, equals the opposite length divided by the hypotenuse. Okay, so if I'm solving this equation to find x, I need to reverse this operation here. The opposite of dividing by 15 is to multiply by 15. Okay, so when I multiply the right hand side by 15, this cancels. And on the left hand side, I'm just going to multiply by 15. And when I put that in the calculator, that is going to give me the value of x. And it gives me 13.2442 and so on. And for a distance, we need to round this to 3 significant figures. So I'm going to count 1, 2, 3. Check the 4th figure, it's smaller than 5, so it doesn't change the number 2 here, so I'm left with 13.2 centimeters. In question 14, it says that Hong has $4,000 to invest. She invests $2,000 at a rate of 2.5% per year simple interest. She also invests $2,000 at a rate of 2% per year compound interest. We have to find the value of each investment at the end of 8 years. Okay, so before we start, I just want to draw your attention to the 2 formulae that I've written down, okay? This one up here is the formula to work out simple interest. So it means that we multiply the principal amount, P, so the start amount, by the rate of interest, the percent, multiplied by the time in years, and we divide this by 100, okay? And for compound interest, we take the principal amount, so the start amount, and we multiply it by 1 plus the rate of interest out of 100 raised to the power of time in years, and then we subtract the principal amount, okay? So that's to calculate simple interest. So in this question, it says find the value of each investment at the end of 8 years. So that means we have to work out the total amount of money that she has at the end of the 8 years, first for simple interest and also separately for compound interest. So let's start with simple interest. So to work out the simple interest, we have to take P, the principal amount that she starts with. We multiply this by the rate of interest, so 2.5. And then we times by the time in years, so 8, and we have to divide this by 100. Okay, so this calculates simple interest, but to work out the total amount of money, we have to remember to add the amount that she started with. Okay, so when you calculate this, you get 2,400, so that is the value of her simple interest investment. Next, let's look at compound interest. Okay, so we have to take the principal amount that she started with, so 2,000 again. We multiply by 1 plus the rate of interest, so this time it's 2%, so 2 out of 100. And we raise this bracket to the power of time in years, so 8. But in this question, we don't need to subtract the principal amount, okay, as this is if we were calculating the compound interest. But because we're calculating the total amount of money that she has after the 8 years, we only need to calculate this part, okay? So when you pop that in the calculator, you find that it comes to 2,343.3187 and so on. Okay, and I'm going to round this to 2 decimal places. So I'm going to have 2 numbers after the decimal point as it's a question with money. Okay, so I'm going to check the 3rd number after the decimal point. The 8 rounds this one up 1, so I have 32. Okay, so that is the value of her compound interest investment. In the second part of this question, we have to find the overall percentage increase in the $4,000 investment at the end of 8 years. So whenever you have to work out percentage, increase, decrease, change, profit, loss, you can use this formula. Okay, you have to work out the difference, divide by the original amount, and multiply by 100. Okay, so in this question, the difference is going to be the amount of money she had at the end minus the amount of money she started with. Okay, so the amount of money she had at the end was 2,400 from the simple interest investment, 2,343.3187 and so on for the value of the compound interest investment. Okay, so that's the total amount of money she had at the end. To find the difference, we have to subtract the amount that she invested in the first place, so 4,000. Then we have to divide by the original amount. So the original amount that she invested was 4,000, and then we times that answer by 100. Okay, so when you put that in the calculator, you get 18.5829 and so on. And I'm going to round this to 3 significant figures. So I'm going to count 1, 2, 3, check the 4th one. This 8 is going to round the 5 up 1. So I'm left with 18.6%. In part 3, it says find the number of complete years it takes for the compound interest investment of $2,000 to become greater than $2,500. Remember, this is the same question as before, and the rate of interest for the compound interest investment was given, it's 2%, okay? We also know the principal amount, the start amount is 2,000, but we need to work out the number of years, i.e. the time. Okay, so remember, to calculate compound interest, you take the principal amount, so the start amount, you multiply it by 1 plus the rate of interest out of 100, and you raise it to the time in years. Okay, so remember, T is what we're trying to work out. So what I suggest you do in this question is use trial and error to sensibly guess the answer. Okay, we know that in the previous part of the question it was 8 years and it was smaller than 2,500, so I'm going to try when the number of years is 11 to start with. Okay, so when I put this into the calculator, okay, so my calculation to work out the value of the compound interest investment when it's a time of 11 years gives me 2,486.7486, okay, which is not greater than 2,500, but it's not far off. So next I'm going to try the time in years, 12, okay, so this time we're investing for 12 years. Okay, so when you put this into the calculator, you get 2,536.4835. So I can see that when I go from 11 years to 12 years, the value of the investment is now greater than 2,500. Okay, so the number of years must be 12. In part B, it says that Alan invests $5,000 at a rate of R% per year compound interest. At the end of 15 years, the value of the investment is $7,566. Find the value of R. So let's just take a look at the information that's been given first of all. So we know the amount that Alan invests is 5,000. Okay, so that's the principal amount. We also have the time in years of the investment, 15. We also know the value of the investment at the end of those 15 years, okay? And we're trying to work out the rate of interest R, okay? So just as a reminder, I've written down the formula to calculate the compound interest total, Okay, remember this is the formula to calculate the value of the investment, so the total amount of money that Alan has at the end of 15 years. Okay, so what we're going to do is substitute in everything we know so that we can then solve the equation for R. Okay, so I'm going to start by writing down the principal amount, so 5,000. Then we multiply this by 1 plus the rate of interest, so R, out of 100. And we raise this bracket to the power of years, so 15. Then remember you have to form an equation, so you have to put this equal to the value of the investment after the 15 years, which is 7,566. Okay, so now we have to solve this equation for R. So the first thing I'm going to do is divide everything by 5,000. Okay, so when I do that, I get this side cancels, okay, then I'm left with 1 plus R over 100 in brackets, still raised to the power 15. And remember, we have to divide by 5,000 on the right-hand side as well. Okay, whenever you do something to one side of the equation, you must also do the same thing on the other side. Now, the opposite of raising something to the power of 15 is finding the 15th root. Okay, so when we do this on the left-hand side of the equation, this cancels to leave me with 1 plus R over 100. And then on the right-hand side, we have to find the 15th root of 7,566 out of 5,000. Okay, we're nearly finished. Next, we have to subtract 1 on both sides. Okay, so when I subtract 1 on the left-hand side, this cancels to leave me with R over 100. And on the right-hand side, we're just finding the 15th root of this fraction, and then outside of this root we're subtracting 1, and the last step is the opposite of dividing by 100, so multiply by 100. Okay, so when we multiply the left hand side by 100, this cancels to leave us with R, and on the right hand side we have to make sure that we multiply all of what we've written down so far by 100. Okay, so I would pop it in brackets like this before you times by 100, and when you put all of this into the calculator, you get 2.7999 and so on. And I'm going to round this to 3 significant figures, so I'm going to count 1, 2, 3, check the 4th figure, and this 9 rounds this 9 up 1, okay? So this changes to a 10, which then in turn rounds this 7 up to an 8, okay? So I'm left with 2.8 or 2.80%, okay? So that is the rate of interest. In question 15, we have to find the value of y when u is equal to 7 and x is equal to 25. So all you have to do in this question is substitute both of these numbers into the equation above. So to find y, we have to find the square root of u squared, so 7 squared, multiplied by x, which is 25, okay? And when you work this out, you should find that you get 35, okay? In part B, it says rearrange the formula to write x in terms of u and y. So that means we have to rearrange this equation to make x the subject. So it has to say x equals, okay? So I'm going to undo the operations around x here until x is by itself. So the first thing I need to do is the opposite of square rooting. So I'm going to square both sides of this equation. So when I square the left-hand side, I get y squared. And when I square the right-hand side, it cancels out the square root. Okay, so now I have this. Okay, next I'm going to divide both sides by u squared. Okay, so when I divide the left-hand side by u squared, I have y squared over u squared. And on the right-hand side, this cancels to leave me with x. Okay, so I've made x the subject of the formula, so the answer is y squared over u squared. In question 16, it says that A is the point 72 and B is the point -58. We have to calculate the length of AB. So I think it's helpful just to visualize what's going on and just do a rough sketch of what that would look like. Okay, so I've plotted point A and B. We're trying to work out the length of AB, so the length of this line here. So you should be able to see, if I just draw in some dashed lines here, there's a right angled triangle.
Okay, so we're just working out the hypotenuse of a right angle triangle, so we're using Pythagoras' theorem to do that. Okay, so you can see the height of this triangle here is the difference between 8 and 2 along the y-axis, so 6. And the base of this triangle is the difference between those x-coordinates, so 12. Okay, so you can see those two distances. So if we're working out the length of the hypotenuse, let's call it x, you have to find the square root of those two lengths I've just written down, squared and added together. Okay, so when you work that out, you get 13.416 and so on. So I'm going to round that to 3 significant figures, 1, 2, 3. The fourth figure is 1, so it's smaller than 5, so it doesn't round this 4 up. So I'm left with 13.4. In part B, it says find the equation of the line that is perpendicular to AB and that passes through the point -1, 3. Give your answer in the form y equals mx plus c. So to answer this question, I'm going to work out the gradient of the line AB, as then I'll be able to work out the gradient of the perpendicular line. Then using that new gradient with the point that's been given here, -1, 3, I can use y equals mx plus c to solve and find c, the y-intercept, and then I'll be able to write down the equation, okay? So the first step is to work out the gradient, and I'm going to call the gradient m, of the line AB. So to work out the gradient, I'm going to use a method called rise over run. The rise is the difference in the y values of A and B, and it doesn't matter which way round you subtract these. I'm going to do point B minus point A, so I'm going to have 8 minus 2. Then you divide by the run, which is the difference in the x values, so -5 take away 7. And when you calculate this, you should find that you get -1/2. So that is the gradient of the line AB. So now I have to work out the gradient of the perpendicular line. Okay, so the gradient of the perpendicular line is +2. The easiest way to remember this is you have to change the sign. So if this first gradient's negative, this gradient's going to be positive and vice versa, and you have to switch upside down. So 1/2 would change to 2/1, and 2/1 is the same as 2. Okay, so there's the gradient of the perpendicular line. So now we have, so far in the equation, y equals 2x plus c, okay? We know the gradient is +2. Now to work out the value of c, we substitute in our values x and y from this point given into our equation. So I'm going to replace y with +3 and replace x with -1. And now I can solve for c. So 2 multiplied by -1 is -2, so 3 equals -2 plus c. Then if I add 2 to both sides of this equation, I find that c is equal to 5. So the equation of the line that's perpendicular to AB and that passes through that point -1, 3 is y equals 2x plus 5. In question 17, it says the area of the triangle is 50 centimeters squared. Calculate the value of sine x. So because we're talking about the area of a triangle, I've written down the formula to calculate the area of a triangle. A equals 1/2 AB sine C. Remember, this is given to you at the beginning of the paper. Okay, so before I try and use this equation, I'm just going to label my triangle. Remember, capital C is the unknown angle here, x, and the sides A and B are always either side of this angle C. Okay, so now I need to substitute all the information that I can into this equation so that I can find the value of sine x. So I'm going to start by replacing capital A, the area of the triangle, so 50. And this is equal to 1/2 times A, so 18, times B, which is 13, times sine x. Okay, so because we're working out the value of sine x, we have to make sine x the subject of this equation. So we can see that sine x is being multiplied by all of these numbers. So what we're going to do is divide everything by these numbers. Okay, so I'm going to divide 50 by 1/2 times 18 times 13, as that will give me
sine x, which is what I'm trying to work out. So when you put this into the calculator, you find that you get 0.42735 and so on. And I'm going to round this to 3 significant figures. So 1, 2, 3. The fourth figure is smaller than 5, so it doesn't round the 7 up. So I'm left with 0.427. In question 18, we have to solve this equation, and to do that, I'm going to cross-multiply. All that means is I'm going to multiply the equation by both denominators at the same time. So if I multiply by this denominator here, 4, okay, if I multiply the left-hand side of this equation by 4, I then have 4 lots of 3y for the numerator. If I multiply the right-hand side of this equation by 4, this denominator is going to cancel and I'll be left with positive 3. Next, if we take the other denominator, 2y minus 1, and we multiply. On the left-hand side, if we multiply by that denominator, this cancels, okay? And if we multiply by 2y minus 1 on the right-hand side, we get 3 lots of 2y minus 1. Okay, so we call it cross-multiplying because this denominator ends up here and this denominator ends up here. So we're like cross-multiplying, okay? So now the equation is looking much simpler to solve. Okay, remember we're solving to work out the value of y. Okay, so next I'm going to expand the brackets. So 4 times 3y is 12y. And 3 times 2y is 6y, and 3 times negative 1 is negative 3. Next, I'm going to move all y terms over to the left-hand side of this equation. So I have 12y minus 6y equals negative 3. So 12y take away 6y is 6y. Okay, so now the equation says 6y is equal to negative 3. And the last step is to divide everything by 6 so that y is equal to negative 3 over 6, which simplifies to negative a half. So that is the value of y. In question 19, the cross-section of a prism is an equilateral triangle of side 6 centimeters. The length of the prism is 20 centimeters. Calculate the total surface area of the prism. So I thought it was helpful to do a sketch of this prism just so you can see what shapes we need to work out the area of. Remember, the surface area is just the area of all the surfaces added together. Hopefully you can see there are 2 identical equilateral triangles at either end. Okay, so we've got to work out the area of 2 triangles. And then there are 3 identical rectangles. Okay, so we've got to work out the area of 2 triangles and 3 rectangles and then work out the total. Okay, so for area of a triangle, I've written down the formula. Remember, it's given at the beginning of the paper. A half AB sine C. In this triangle here, A and B are both 6. Remember, it's an equilateral triangle. And you know that the angle C is going to be 60 degrees because all of the angles in an equilateral triangle are always 60 degrees. Okay, so I'm going to start by working out the area of 2 lots of the triangle. So remember, area of a triangle is a half times A, so 6, times B, which is also 6, times sine of the angle, so sine 60. Then I need to add on 3 of the rectangles. And the rectangle, let's look at the base here. You know this length is 6 because this was an equilateral triangle at the start. So the area of the base rectangle here is 6 by 20. So all of those rectangles will be found in the same way. And when you make this calculation, you should find that you get 391.1769 and so on. So I'm going to round this to 3 significant figures, 1, 2, 3. This fourth figure doesn't round this one up, so I'm left with 391 centimeters squared. In question 20, we're given an equation, y equals, and its derivative here, dy by dx. We have to find the value of k and the value of u. So what I suggest you do in this question is take the equation from the beginning and find the derivative. Work out dy by dx, as it will give you an expression that's written slightly differently to the one over here, but essentially they're equal to each other. So then you can compare the two and work out the values of k and u. Okay, so let's go back to this equation.
at the start, and we're going to differentiate. So you take the power here, k, and you multiply it by this value. K times 2 is 2k. Remember, the power on the x is going to decrease by 1, so we're left with x to the power of k minus 1. Then if we differentiate this term here, we take this power 7, we multiply it by this value here. 7 times u is 7u. And again, the power on the x is going to decrease by 1, so we're left with x to the power of 6. Okay, so here's our derivative. So remember, this dy by dx equals this one here given at the start of the question. Okay, you can see the power here, k minus 1, is the same as this power. Okay, and likewise here the power is 6 on both terms. So let's compare this part here, okay, that's being multiplied with x to the power of k minus 1. This 2k must equal 18. Okay, so if 2k is equal to 18, k has to equal 9, because 18 divided by 2 is 9. So there's our value of k. Next, we can compare or equate 7u with 21. Okay, remember, these have to equal each other. They're the same. So to find u, we have to divide by 7, and 21 divided by 7 is 3. So there is our value of u. In question 21, we have to simplify this algebraic fraction, and to do that, I need to factorize. So I'm going to start by factorizing the numerator. So in front of the brackets, I should have 5p. This is the highest common factor in these two terms here. And inside the brackets, that means I need p minus 4. Remember, when you expand these brackets, it's meant to take you back to what you started with, okay? Now, if I factorize the denominator, in front of the brackets, I have the number 2, okay? That's the highest common factor. And so inside the brackets, I should have p squared minus 16, okay? So we haven't quite finished. The numerator is as far as we can go, okay? But the denominator, we can factorize further, as this part inside the brackets is what we call the difference of two squares. Difference because this is subtract, and squares because this is a square letter and this is a square number. Okay, so when you see the difference of two squares, it means you can factorize further. You need to replace this single set of brackets with a double set, like so. Then you can fill in your values of p. Okay, remember, p multiplied by p gives you p squared. Then inside the brackets, you will always have 1 plus 1 minus. And then to find this number here, you take the number 16 and square root it. The square root of 16 is 4. Okay, if you need practice at the different types of factorizing, please do have a look at my channel, as I have lots of lessons on this subject. Okay, now we just have to look at this factorized form to see if we can cancel anything. Okay, and I can see that there's a p minus 4 on top, but also underneath. And whenever you divide something by itself, you get 1, which is why it cancels. So we're left with 5p divided by 2p plus 4. Okay, and that is the answer. In question 22, the diagram shows triangle OPT. In the diagram, O to T is equal to T, and O to P is equal to P. And you can see those vectors T and P have already been labelled on the triangle above. Then it says OK to KT is equal to 2 to 1, and TL to LP is also equal to 2 to 1. Okay, so before I answer this part of the question down here, I want to take a closer look at these ratios that have been given and try and show what that means on the diagram first. So if we look at the line OK, we can see this is divided into two parts. So what I'm going to do is I'm just going to draw some dashed lines along O to K, like so, to show that there are two parts along that line OK. Then from K to T, there is one part, and that's already shown there, okay? So all the way along the line OT, there are 3 parts altogether. Then if we look at T to L, here there are 2 parts, okay? So if we look at the line TL on the right, I'm just going to divide that section into 2 parts, and then L to P is 1 part. So just like with the other line, the line T to P is divided into 3 sections. Okay, so now in part A, it says find in terms of T and P in its simplest form, P to L. So we can see to get from P to L, we're travelling a third of the way along PT. Okay, you can see that from P to T there are 3 sections and we're only travelling along 1 section. Okay, so it's a third of PT. So now what we have to do is work out how to get from P to T. Okay, and we can do that by starting at P and travelling like this to get to T. Okay, so using the vectors PT that were given at the start. So for this part here, we're travelling against the arrow here for vector P. So I have to remember to reverse the sign, so it's negative P. And then for this part along here, I'm travelling in the same direction as T, so it's plus T. Okay, so that's the answer. You can leave it like that, or if you like, you can expand the brackets. Either way is fine. In part 2, we have to find from K to L. So here's K on the diagram, here's L. Remember, it doesn't matter which way you travel to get there. You should get the same answer whether you travel via T or via O. I'm going to travel this way, via O, because it incorporates my answer previously, P to L. Okay, but like I said, it doesn't matter if you travel the other way, you'll get the same answer. Okay, so if I travel in this direction, I'm starting at K, I'm traveling to O, then from O, I'm traveling to P, and then lastly, I'm traveling from P to L. Okay, so I'm just stating the direction in which I'm traveling to begin with. Okay, so to get from K to O, you can see that we're traveling against the vector arrow T. And remember, O to K is 2 parts of the line OT. So it's going to be negative 2/3 T for the first part. Okay, then from O to P, this one's nice and easy. It's just going to be plus P. Okay, we're going in the correct direction for the arrow. And then lastly, P to L. Remember, this is the part that we worked out up here in part 1. Okay, so I'm just going to replace P to L with negative 1/3 P plus 1/3 T. Okay, so now all that's left to do is to simplify. So I'm going to start by looking at my T terms. So I've got negative 2/3 T plus 1/3 T, which is negative 1/3 T. And then if I take the P terms, I've got 1P minus 1/3 P, which is 2/3 P. And that is the answer. In part B, it says KL is extended to the point M, and we're given K to M is equal to negative 2/3 T plus 4/3 P. We have to show that M lies on OP extended. So I've just added to the diagram above, I've extended the line KL to a point that I've labelled M, and we have to show that this point M lies on that extended line from O going through P all the way to M. Okay, so if we can show that O to M is some multiple of O to P, we're proving that M lies on OP extended. Okay, so what I'm going to do is I'm going to try and work out from O to M. Okay, and we want to try and use what they've given us here, K to M. Okay, so to get from O to M, I'm going to travel from O to K, we know how to work that out, and then from K to M, okay? And remember, we've been given K to M up here, okay? So to get from O to K, so just look back up at the diagram here, you can see that it's 2/3 of the way along the entire line OT, so it's going to be 2/3 T. And then K to M is what's given in this question here. So negative 2/3 T plus 4/3 P. Okay, so now I can just simplify. I can see I've got positive 2/3 T and negative 2/3 T, which cancels to 0. So I'm left with 4/3 P. Okay, so now it says that O to M is equal to 4/3 P. So we've shown that OM is a multiple of OP, because remember, O to P is equal to vector P, and O to M is 4/3 of P. Okay, so it's a multiple of P. Okay, so make sure you show your working out in a show that question. If you want to really just guarantee that you get full marks, you can also write OM is a multiple of OP. In question 23, it says Serge walks 7.9 kilometers, correct to the nearest 100 meters. The walk takes 133 minutes, correct to the nearest minute. Calculate the maximum possible average speed of Serge's walk. Give your answer in kilometers per hour. So remember, to work out speed, you have to divide the distance by the time. And if we want the average speed to be at its maximum, so as big as it can be, we want the distance to be as large as possible, but the time to be as small as possible. Okay, so let's have a look at the distance up here and try and find the upper bound for the distance, okay? And then afterwards we'll look at the time, and here we have to find the lower bound, okay? So it's rounded correct to the nearest 100 meters for the distance, and I noticed that here it's given in kilometers. So 100 meters is 0.1 kilometers. Remember, you have to divide by 1,000 because there are 1,000 meters in a kilometer. So if I want to work out the upper bound, I take this value here and I divide by 2, which gives me 0.05, and then I have to add 0.05 to 7.9, which gives me 7.95. So this is the upper bound for the distance that he walks, okay? So I'm just going to write that down here, as that is our distance value, okay? So next we're going to look at time, and it's correct to the nearest minute, okay? So I'm going to divide 1 minute by 2, which gives me 0.5, and this time to find the lower bound I have to subtract 0.5 from 133, which is 132.5. So that is the lower bound for the time. Okay, so now all that you have to do is just check the units here. It says kilometers per hour. We know the distance is already in kilometers, that's okay, but the time is in minutes, and we have to make sure it's in hours. So remember, there are 60 minutes in 1 hour, so we have to write the minutes out of 60. Okay, and now we can work out the calculation to work out average speed. So pop that all in your calculator, and you should find you get an exact answer. It's 3.6. In question 24, it says the straight line y equals 2x plus 1 intersects the curve y equals x squared plus 3x minus 4 at the points A and B. Find the coordinates of A and B. Give your answers correct to 2 decimal places. So we're looking for 2 points of intersection. So we're solving the simultaneous equations here. You can see that both equations are rearranged so that y is the subject. So since y is equal to y, we know that 2x plus 1 is equal to x squared plus 3x minus 4. Okay, so your first step is to write down this equation in x. So we can first solve for x. Okay, so what you need to do first is make sure all terms are on one side of the equation. So I'm going to move everything to the right-hand side so that this equation is equal to 0. Okay, so I've got one x squared term that hasn't changed. Here, if I look at the x terms, I've got 3x minus 2x, which is 1x, and negative 4, take away 1, which is negative 5. Okay, so we have to solve this quadratic equation. Now, we can't factorize this equation, so I'm going to use the quadratic formula to solve this quadratic. Remember, the quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. And the values of a, b, and c here are 1, positive 1 for a, +1 for B, and then C is -5, okay? So if I substitute my values into the quadratic formula to find x, I get x is equal to -1 plus or minus the square root of B squared minus 4 lots of A multiplied with C, all divided by 2A. Okay, and when you put that into your calculator, once with the plus and then afterwards with the negative, you get two different values. You get 1.79128 and so on, or -2.79128 and so on. Okay, so remember we have to round these answers to two decimal places. Okay, so we want two numbers after the decimal point. So if I take this value to start with, I want two numbers after the decimal. This value I need to check. This one doesn't round the 9 up, so I'm left with 1.79. Then if I look at the second value here, check the rounding here, check the third number after the decimal point, and again it's a number 1, so it doesn't round this 9 up, so we're left with -2.79. Okay, so we have the x values. Now we have to work out the corresponding y values, and the easiest way to do this is to take this equation here, y equals 2x plus 1, as this tells you how to work out the value of y. To work out y, we take x, we times it by 2, and we add 1. So we're going to substitute our x values one by one into this equation to calculate the y values, okay? So I'm going to start by substituting in this x value here. So y is equal to 2 lots of 1.79128. So do use your exact value, okay, when you do this calculation. And when you do that, you get positive 4.5825 and so on. Okay, and if I round that to two decimal places, it's going to be 4.58. Okay, so there's the first value. Next, I'm going to substitute into this equation here the second x value. So 2 lots of -2.79128 and so on. And don't forget to add 1. And this time I get -4.5825 and so on. Okay, so if I round this one to two decimal places, I get -4.58.